Okay, now I started recording. Hey, good morning, everybody. Actually, good afternoon. Whatever, it doesn't matter. It's a holiday here in the U.S., so I figured why not kick off a midday stream and kind of cover some of the new features in Mass Transit 7. Um, just wanted to kind of repeat a couple things. Mass Transit 7 was released this week, so there's a lot of new documentation on the site. Covers a lot of the new features. Um, yeah, so one of the things I wanted to cover today about gosh, I guess it was maybe 4 or 5 years ago, I put a feature together called Turnout to deal with the situations where you have like consumers that take longer than a typical message consumer. And I'm talking stuff that runs for like 5, 10 minutes, anywhere up to hours. Typically, those are kind of scheduled job kind of things. And you don't usually want to run these in a consumer because if you lose your broker connection, some other consumer is going to start up and start running that message again. We ran into this a lot with Azure Service Bus when we were building a system with one of the teams I used to work with. And what we found is that the lock refresh time on Azure Service Bus, every now and then the client would just forget to do it or couldn't get through to the host and configure it. And the redelivery count would kick in because the message lock would be lost. And so then we'd end up with like 5 or 6 processes all doing a hardcore import of data, parse everything else. So everybody was like, we're getting duplicates. It was just, anyway, it was a pretty bad time. But so this turnout feature was originally created for that solution. And we tried to do it all kind of in memory and everything. And it was all using transports. Anyway, never supported very well. You know, it fit a couple of use cases. For version 7, I wanted to take some time to kind of rewrite that. And what it does, and if we go into advanced in the documentation, you can see, uh, message consumers, again, as it says, they're meant to be fairly short lived. I mean, anything up to a minute, a couple of minutes, you aren't going to really need this. This is really for those cases where you have kind of like background processing and you want to control that. So with Mass Transit 7, I introduced a new interface called iJobConsumer. And what I've done is I've put together a sample project because, again, this is code. This isn't just me reading docs to you. So I'm going to just give you the doc link. You know, it's in there under advanced or job consumers if you're like multitasking like I do and reading at the same time. Plus, it just gives you a little, information around. I'm going to bring up the sample. And what I have here is a simple sample. I didn't want to do this in the existing Twitch sample and the others because honestly, it's a lot of overhead to take in. And I wanted this to be pretty simple. And by simple, I mean it's a solution with 4 projects that uses RabbitMQ and has everything running in an ASP.NET host for the service. So by simple, I mean like sort of simple, but not really. We have a single message contract. It's called Do It. And the Do It has a duration. And the duration lets us say, hey, we want to kind of control how long this is going to take. Do It is going to be published by a simple client that I have. Which is just going to say, give me a duration in seconds, and then it's going to create a time span and actually publish that message contract. So simple console app, doesn't do a whole lot. Everything's good. The consumer, as you might imagine, is really complicated. I tried to put as much work as I could into this. It calls await task.delay with that duration. So pretty predictable how long it's going to take. In fact, like right on to within a couple milliseconds. So I'm going to throw this off and see what happens. I'm just going to hit F5 and that'll run it in this little window right here. You can see it's going to bring up ASP.NET. It's going to start all that stuff. RabbitMQ is going to start up. I got a couple queues created. You can see that it's fairly lightweight, not a whole lot going on here. And yeah, there, it's all set up. Consumer's okay. Now I'm going to go out to the console and I'm going to run that console app. And I'm going to give it a duration in seconds. Let's just say 5 seconds. I didn't put any logging in this because I kind of just used the built-in mass transit logging. So in about 5 seconds, we'll see that a message was received. It was the do job consumer, and it took 5 seconds to run, plus, about 14 milliseconds worth of overhead and processing and serialization and all that fun stuff. If that really took that long. It was the first time. Probably be quicker the second. I don't know if I do it again with 1 second, but that'll rock. But that'll be nice and quick. Oh, twice the overhead. That's awesome. Great. Anyway, So that's the simple program we have. Now, if these are going to take a long time, we want to switch to this kind of job consumer mentality. And that takes a little bit more work than what we're doing because, again, the first version of Turnout was really simplistic, and yet it was kind of flaky to understand. Um, this is going to be a little different. So we're going to fire it up. We're going to do a couple of changes first. We're going to go to the do job consumer, and we are going to change this to iJob consumer. That is going to pull in the job service namespace. And you'll notice right away, there's a different syntax for this interface. It's going to have me implement a new method. And this method is called run, where it passes a job context. Now, job context has a different set of properties on it, but we're just going to move our business logic down here. And I'm using business logic really loosely as far as the term is concerned. And you'll notice message isn't here. I believe it's actually called job, okay? So instead of context.message, we're getting context.job. And that is basically the message. It's what we scheduled up for. It's in there. There are a few other things in here, like you can see a lot of the message properties are here. And there's some notifications that are called under the hood. It has some things. I mean, it is sort of like a consume context, but it's seriously abbreviated. You can still send messages, you can still publish messages, you can do things like that, but consume context is gone because the consumer doesn't keep running while this job is running. These run asynchronously outside of a consumer. They're started and you don't have any other, really recourse into them. So, I mean, you don't have the consume context, so you can't do consume contexty things. So by changing this consumer to a job consumer, if I try to run this right out of the box, it's going to crater. It needs some things that just aren't there out of the box. So the docs will kind of spell this out a little bit, but I'm going to do it from the service side. So where the do job consumer is used, I'm just using the MassTransit container configuration. And right now I'm just calling configure endpoints. Job service is one of the first things that's actually using Conductor. Conductor, for anyone who hasn't been, part of kind of the contributor structure of MassTransit for a while, Conductor is like let's just face it, it's my white whale. It's my full service meshy auto discovery type system that's going to run around in MassTransit. Little bits and pieces have been here and there for a while, but it's been long. I mean, those are hard problems to solve, and there's a lot more commonly used capabilities that are out there. But this is the first kind of dip into making that actually part of something that we require. So to configure Conductor, I actually have to say service instance, and this gives me a service instance. Now within Conductor, a service instance means typically when you run MassTransit with receive endpoints, if you have multiple instances of your service, all of them will read from the same queue and do just general out-of-the-box competing consumer. What a service instance configuration does is it allows me to uniquely identify all those instances and have them sort of collaborate. So I'm going to create this with some options, and then I'm going to configure my job consumer there. And I can just move this right here and say instance.configure endpoints. So it supports the same kind of configuration in that respect, and I can configure those endpoints. But I need to create some options because I need to tell the service instance how to behave. So we're going to new one of these up. We're going to say .enable instance endpoint. What this will do is it will create an endpoint for each instance of the service. So if I run 3 or 4 copies of it, each one is going to get their own temporary endpoint so that they're independently addressable. And that's needed because job service requires each instance to have an endpoint so that it can communicate directly with the node that is running the asynchronous task. There's some other things in here too, such as enable job service endpoints. We're going to throw that in there too. We need some job service endpoints. We are also going to throw in, what else do we want? We want to set our endpoint name format. We don't have to do that because we're going to set it out here. We're going to come out here and say, we're just going to leave it as right now. We'll use the default one. No need to get crazy there. All right, so we've set up some configuration options. I do think the enable job service endpoints, does it have a callback? I think so. Oh, it looks like it's pretty close. I don't think I can pass anything in here. Okay, so I've got that set up. I don't think I need to do anything else. That is going to enable the job service endpoints, it's going to enable the service instance, and it's going to configure my do job consumer on that instance. I'm going to try to run this, see what happens. Worst case that can happen is it doesn't work, right? Okay, it looks like it worked. Okay, the first thing you're going to see is that a lot more things happened when the service started up. Let me kind of expand this out a little bit to kind of show what's going on here. So this time when we started up, we declared a lot more exchanges. You can see that there's some conductor exchanges for linking and unlinking services. This is done for service discovery. You can see that there were submit job, cancel job, start job. These all look kind of jobby type things, which is kind of interesting. You can see that our instance endpoint was created on instance underscore long name temporary equals true. You can see that the job service start job and that the source do it, which is our contract, has a destination to do job, the same do job consumer because it follows our naming conventions, didn't change any of that. But then it also registered a contract for submit job of do it, which is another thing we have going on there, which is kind of cool. Yeah, so let's just see what happens if I go and try to submit a job. Mind you, don't know if it'll work, but we'll find out. Let's do 5 seconds, see what happens. Oh, we had some things happen. First thing we did, it looked like we set the job limit, we did some things, and we submitted the job and nothing happened. Okay. So clearly I didn't configure something. Wonder what it is. Now I'm stuck. Now I gotta go read the documentation. Always fun. By the way, these are all completely unrehearsed. So, when stuff doesn't work right, it's like, let's go see what happened. And again, I'm pretty sure that we have to call instance.configure job service endpoints. That's going to be my guess. Looks like it's going to work so far. Okay. I wonder what this enable job service endpoints does. Now I'm really curious. Oh, it adds the job service option. Guess that maybe. I wonder if that's something I finished or didn't finish. I'll have to look at that. But I'm going to add this instance.configure job service endpoints because the job service, submit, start, cancel, all of those things, there has to be some sort of coordinator with that. One of the other issues with the early turnout is that because these tasks were running asynchronously, there was no way to keep track of how many were concurrently running. So because the messages would get read off the queue, there was no way to do like prefetch counts or anything like that to limit them. So it would just spew through 100 messages and have 100 concurrent tasks running. And if you're encoding videos and you have 2 instances running on your cluster, it's going to eat it up pretty bad. So one of the things I wanted to do is make sure that we supported concurrency limiting and also supported retry. So there's a series of 3 state machines that are created when you configure the job service endpoints. And now when I run this, we'll see those fire up. And what we'll see is a whole bunch more consumers come up. So now we're going to see things like, oh, wow, we actually ran the job, I bet. Because that job was probably still sitting in the queue, would be my guess. Yeah, because the job service options were there. So you can see there's 3 state machines. There's the job state machine, there's the job type state machine, which uses the message type for the job type, and then there's the job attempt state machine. And these 3 work together to not only track all of the attempts of running a job, but to control things like starting them and to enforce the concurrency within the job type consumer, and to also schedule each attempt, and upon attempt failure, schedule retries as well. So as I kind of look through this, I'm seeing contracts come up. I'm seeing up. Oh, because my message probably didn't go anywhere. because when I did the job submitted, it was probably lost because none of these services were created yet. I do see a log message here that the job service started, so that's good. The job service runs on the node. Wow, I have both serial log and .NET logging going. That's exciting. Okay. So now I'm going to go ahead and run this again while it's running, and then I'm going to go submit a new job this time. So all of that should be up and running. It's been run once. So all of the bindings are now in the broker. So I'll do a .NET run. I'll say I want it to run for 5 seconds, and you can already see things are going to work here. We process this. We had a error, which is awesome. What's the error? Payload not found, message scheduler context. Oh, that's a fun one. Means I didn't configure message scheduler. Oh, yeah, because I didn't configure the message scheduler. Yeah, that's going to be real hard to schedule messages if there's no message scheduler configured. So let's go change that. Let's say p.add rabbitmq message scheduler. This is a new method in version 7 to both add the message scheduler to the container and also configure it on the bus. It kind of sucks that you have to do both, but life's like that sometimes. Now we'll kick it off. We actually have a scheduler. Probably gonna have to run a new instance of the job. Probably should have just run quartz, but that's okay. All right, we'll try it with just the broker scheduler. Never actually tried it with just the broker scheduler before, so we'll see what happens. Oh, that looks better. That looks a lot better. Okay, so we had a job come in. We had our job submitted. It went to the job type saga, which created an instance for that job type. Oh, because all my sagas are in memory right now, so they don't remember anything, which is awesome. I can just restart and it'll all be good. So it created the job type for that job type. It set the concurrent job limit to 1, as you can see here, which is the default. It went through and processed the job submitted. Went to the, which saga is that? We see a saga. We use the job type saga to actually allocate a job slot. So it'll actually allocate and keep track of those. It says there's one available, so it allocates it out. We do the job slot allocated. We go out and we say we're going to start job attempt, which creates an attempt in the state machine. The job attempt saga creates it, adds it. It sends the start job to the consumer. The start job consumer processes within, less than 1/10 of a second. It's running. And then we see the receive job attempt created. Everything's good there. Now we get down to job attempt started. All that looks good. I'm looking for the receive that I actually ran the job. There it is. Receive. Long run, 5 seconds. There's our actual job type consumer that actually ran. You can see that right after that, we removed the job, ran to completion. So the job service that's running on that node monitored that async task. And when that async task completed, it went out and sent the job attempt completed event, which was received by the job attempt saga and also the job saga. Cleans everything up, marks job completed, moves it to the type. In this case, it just finalizes the saga instance. Looks like I have a unreceived event status check requested is not handled during final state. That'll be a good one to go fix, just to ignore those status check events after canceled. So brokers message schedulers can't cancel unless you're using Azure Service Bus. So since I had scheduled a status check on that job type, I went to cancel it. I couldn't cancel it. It still came in. There's no saga. The saga's in the final state, so therefore it couldn't process it. Therefore it threw a nice little error. It's harmless in this case, but nonetheless, it's annoying. Of course, I'm going to retry it several times just because that's what we do. It's going to eventually publish that fault, but we don't really care about that. We're just going to have to add I'll make a note to add that in. Ignore that message if it comes in that state. So we did it. We ran the job. We saw the time. It did its thing. I'm going to close that out. So that's using the new job service. There are a few options you can configure. Like you can come in here, and I'm going to do this the right way because I feel like it's going to be cool if I do it the right way. I'm going to go into the consumer that I added. And one of the things about all the different container configurations within MassTransit is you have a lot of flexibility on how you configure things. And by flexibility, I mean you can do it this way. I'm going to create a definition for the consumer, which is a consumer definition of do job consumer. And what this lets us do is, if this is in the, when we do an add from namespace, it'll automatically add these so we don't have to go look for it. But this lets us customize the behavior of how things work. So for instance, I'm going to configure the consumer, and I'm going to say consumer configurator.options, and I'm going to say job options of do it. And I am going to configure some of the job options here. So this is how I would plug an options class into the consumer def, which can then be used by the job consumer. I'm going to say options dot set job timeout to, let's just say we're going to give it a maximum of 5 minutes that a job can run before we consider it dead. We'll say, and I can also just set these this way too. It's just the set methods support method chaining, whereas the property assigners and stuff like that obviously don't. Some people like to method chain, some people like to set. I don't really care what you do. I figured it was easy enough to support both. I could say that I'm going to support 20 of these at one time. The real nice thing is I can actually come in and say options.set retry. And just like when you're configuring a use message tree to retry, it uses the exact underlying infrastructure. I can say r.interval, I can say r.incremental, I can say r.immediate. Any of the retry policies that are built into MassTransit can be used. So I can say retry every 5 seconds, up to 5 times. And now if my consumer throws, it's going to actually go out and retry that consumer, which is pretty awesome actually. I'm going to demonstrate that by doing something that I think is kind of fun. Is I'm going to say if context dot. Remember, I have access to everything here. So I'm going to say retry attempt. If it's the first time that I'm trying this, I'm going to just go ahead and throw a, let's just throw an application exception. Not now, I'm busy. And this will mean that the first time that we come into this with a retry attempt of 0, we're going to explode. And I'll act like I'm going to try to do something first. You know, I'll just do like a little 1 second delay or something just to add some stuff in here. But then I'm going to actually say duration minus time span dot from seconds 1. So I actually take the true amount of time because, you know, we want to be accurate. We want to have the same behavior. Now I've added this definition. I've set the job timeout. I've set a concurrency limit. I've set some retry. Let's run it again. So we're going to fire it up. We're going to see a whole bunch of stuff spew out here as it gets up and ready to run. Because I'm in memory, it's going to keep track of it in memory. I do have out-of-the-box support for Entity Framework Core for configuring the repository. I'm going to try to do that, but I really suck at EF migrations, so that might just kind of have to go to the wayside. But .NET run, I'm going to say the duration is 5 seconds. You can see it did set my concurrency limit to 20. So my concurrent job limit of 20 did get carried over right there in the nice big pink 20. You can see we tried to run the job. You can see that we scheduled it. Did we eventually run it already? Must have got through there already. Oh yeah, so we can see that the job faulted. Not now, I'm busy. Line 22. That resulted in a job attempt faulted. It removed the job. We got the job attempt faulted. You can see that it went in and said, okay, well, I am going to schedule a job retry delay elapsed. And it actually schedules that. If you look at the timestamps, it comes in 5 seconds later. and says, okay, well, I just got my job retry delay elapsed because it's using the transport message scheduler. When that retry happens, it says, okay, well, now I need to go get a job slot. And then once I've allocated the job slot, I'm going to try to start that job again. This time the job was successful. We see the appropriate time pass through for the long run due job consumer of 5 seconds. And then we remove the job. It removes the state machine. It cleans up. That scheduled message knocked out again. Same scheduled message because I'm getting that status check requested. I schedule an event for like every minute to check the status of a job, and then once the job completes, I try to cancel it. But since we're using RabbitMQ's message scheduler, we have no way to cancel these messages, so they just sort of sit there in the queue. And when they show up, I just need to add some code in the state machine to handle that message when it's not in the correct state, which of course is final. I do pretty good, but I guess I missed one. I tested this with Court, so I didn't really think about that. But anyway, I'll fix that. But now we can stop this. So that is job consumers. Pretty useful, especially if you're doing background processing. You can, define the options of like concurrent job limits, things like that, retry policies. The retry policy is probably one of the really cool things because it's really setting the framework. This is like the first step. I have two other things that I want this to work with. I want this to work with routing slips to where you can then say, okay, well, I want to try to run this routing slip. And if it fails, I want to automatically schedule the retry. So now that I have the capabilities through these state machines, which these state machines don't care about message type. They actually use a dictionary of string object to actually create serialized message trees and persist them out into storage. So it really doesn't care. You just have one set of state machines that can manage any number of jobs in your system. So that's kind of cool. But yeah, with the retry, I want to get retryable transactions through routing slips in because it saves a copy of the initiating message that's used to create the routing slip. All of that should be doable. There's a lot of conductor capabilities that I really want to build out. So this is just kind of the first step. It's kind of an edge feature. It's something that people may or may not use. I know people who are using it already that help kind of build it, and we're going to have like Azure table storage support for the actual state machines, which is actually kind of cool. Super cheap storage, be able to do it in Azure. And then we should eventually get repo support. It's just a saga. Technically, you could write it yourself. The only thing we're doing is just putting in some out of the box extension methods to configure it. For instance, let's just go do that real quick. So within startup, if I wanted to configure the job service endpoints, this is actually a closure, just like everything else in MassTransit. And I can come in and I can specify these repositories. So I could say, iSaga repository, the different sagas there. I can specify some timeouts and intervals, what the job timeout is, what the slot request timeout is, how long to wait for a job slot before checking again. So like if the jobs are busy, you can say, well, just check every minute because I know the jobs take 30 minutes to do versus every second asking if something's ready. It just slows down the churn on the database. So those Saga repositories, they do default to in-memory by default, which if you think about that, if you have multiple instances and they all have their own in-memory state machine, that obviously is not going to be a good outcome. You're going to want to actually, have a job state machine on there. Let me go into NuGet packages and throw EF core in here just as an example. Framework core. Let me add this to that service. Oh, by the way, those of you looking overhead, I actually did finally get a webcam. Apparently the world is back in stock now, at least until the next shutdown due to Corona. So I actually do have a webcam like actually connected to my computer. I'm not using my phone. So hey, you get to see the floor now instead of the ceiling. Pretty awesome. I know it's exciting. Believe me, it's super thrilling for me too. Use entity framework core Saga repository. So this adds this extension method into the MassTransit namespace. Extension methods for configuration with MassTransit, we try to keep them all in the MassTransit namespace so you don't have to go like spelunking into namespaces to figure out where stuff is. Makes it very easy to resolve. I don't know what all you have to configure here because, again, I really suck at this kind of stuff. But if I look at EF dot, I'm trying to think if there's anything in here. Is it just a connection string? Job Service Saga DB Context Factory. Okay, that sounds exciting. So it sounds like I just have to pass it a new Job Service Saga DB context with the new DB context options. Man, that just sounds like really crazy. Really, there's a better way to configure that. I don't know though. I feel like there's like a weird thing that I'm missing there. Go look at this. Use Entity Framework Core Saga Repository. Okay, so this is passing that. Actually call this. I feel like this is called in some tests somewhere. Anyway, it does have support for EF. I would look at the unit tests to kind of see how that's done. My guess is that Entity Framework Core tests completed. This is like the source of truth for everything. The documentation is good, or getting better. This is like the source of truth. So it looks like we have, oh yeah, because I did this in unit tests with like the test factory thing. Somehow you got to create this DB context and pass like the use. Yeah, because this uses a lot of the test infrastructure, and yeah, you can't actually use resharper shortcuts inside Chrome or Brave or whatever I'm using now. So yeah, but anyway, it's in there. We'll get the docs updated at some point and show us how to do this. If you're familiar with EF, you're probably like, yeah, dude, you just need to do this. But I don't get all that stuff. So yeah. Anyway, it does support it. We have it out of the box. We're getting Azure Table support in there, including mapping for all that. I don't know what this thing does. I feel like this is like a half-baked feature that I put in for this enable job service endpoints, because I'm pretty sure it works without it. So I have to figure that out. I think I was going to put that in, and then I realized you have to actually configure the Saga repository, so it just made sense to put it back inside the service instance. Anyway, enough rambling. Hopefully you find this feature cool. Definitely, if you have questions or anything like that, hit us up on the Discord. Some of the people that are already using it are there pretty regularly. And yeah, I found a bug that I need to fix. That's cool. It's not a breaking bug. It's just annoying for the log filler. But other than that, hey, thanks for joining. I might, depends on the weather. It's pretty warm out and not a lot going on. So I might get a couple more version 7 streams out to show some of the new features. I need to update the rider one because the syntax kind of changed. I just want to go through the Kafka stuff again. But yeah, so thanks for joining. Stick around. Join us on Discord. We'll catch you later. Bye.